Welcome to today's FDTD Go16 Applications webinar. The title of our presentation today is Experimental Go16 Applications for a Flooding Event in the Northeastern U.S. And this is led by Christina Speciali and Neil Stewart from the Weather Forecast Office in Albany, New York. Before we begin, we'll just go over a little bit of protocol here first. First, to announce if you are unable to make the live sessions, all of these are recorded and available on this webpage, which is linked off the visit web pages. Also, if you're interested in speaking to a particular topic, let us know. Either myself, Dan Bicus, or Scott Lindstrom, and we can get you lined up to lead one of these in the future. We'll have about 20 minutes for the speaker to discuss for today, and if you have any questions, you can either send it via the GoToChat, or after the speaker is done talking, we'll have a question and answer period via the phone. And we'll be done by the top of the hour by 20Z. Just a reminder, do not press hold, and also mute your phone when you're not speaking. So at this point, I will turn it over to Christina to lead our discussion.
Okay, so did everyone see the changing of the slides here?
Yeah, I do see your slides there.
Okay, good. Okay, so everyone sees the title then?
Yeah.
Okay, good. So we'll start with an outline of what we'll be presenting. So the first phase of the presentation will be predicting the event, and then we'll be looking at the synoptic and mesoscale contributors. Then we'll show a timeline of the event and how the experimental GO16 satellite imagery assisted with forecasting the event, and then we will offer some conclusions.
So just want to make clear that there was a lead time before this event. WPC did produce in their Day 2 of rainfall outlook. They did show the marginal risk was in place for the New York City and southern New England area, even into most of eastern New England. The top left panel shows the Day 2 excessive rainfall outlook, which was issued around 20Z on Wednesday, July 5th. So the event in question took place Friday, July 7th in the morning. So the Day 2 outlook did highlight the potential for flash flooding in the corridor where our eventual heavy rain event did take place. So there was lead time thanks to the guidance from WPC. In the bottom right-hand panel, it shows the Day 2 excessive rainfall outlook issued by WPC around 20Z on Thursday, July 6th. So this is about the afternoon before the heavy rain took place in the morning hours. And in this graphic, we can see that the marginal risk and the eventual upgrade to a slight risk was concentrated across southern New England, Long Island, New York City. So there was a focus for the threat, but still, that's a pretty wide range and a very highly populated area. Again, this was Friday morning, Friday during the summertime, so not only would you have concerns for flooding impacting the morning commute, but you also have people vacationing to Cape Cod. So this was a very concerning event just because of where it was hitting and the time of day and time of week. But there was advance notice thanks to the guidance from WPC.
Yes, and these excessive rainfall outlooks are meant to prompt the weather forecast offices to determine flood potential. So these are very good first indicators. And then actually on the day of the flooding, the morning before the flooding actually occurred, the Weather Prediction Center actually expanded the slight risk into other parts of southern New York, and even expanded the marginal risk into, let's say, the southern half of New York. So they did expand the threat for the flooding during the morning before the flooding actually occurred, based on more near-term trends.
So here we'll just look at some mesoscale models, and the left panel shows the per experimental run for the total precipitation expected, and these panels show, or the runs are showing the 6 successive runs. The first run you'll see in the loop is from 9Z through 21Z, and this is total QPS, and then each run continues thereafter. Overall, the HER is showing that the region between New York City and Cape Cod, there is the potential for heavy rain, but exactly who is a big jackpot winners, if you will, there's quite a bit of uncertainty. Yes, there is a concentration of heavy rainfall indicated along the Cape Cod and the Canal area, but still that is wobbling and fluctuates with each successive hurricane, so there really isn't a solid answer as to just where in eastern Massachusetts the heavy rain will exactly impact. And again, the same for northern New Jersey, lower Hudson Valley, New York City, Long Island area. It wobbles with each run, so a lot of uncertainty. And then on the right-hand side, we have the NCAR ensemble for total QPF, and that was just really not very helpful for this. It lacks the bullseyes for heavy rain in any of the area expanding between New York City and Cape Cod, so that one really was unhelpful. So overall, this is just showing the need for near-term guidance to really help forecasters indicate just who would see the heaviest rain, and that's where GOES 16 would eventually step in and help forecasters see that clearly.
Yes, we also have some short-range ensemble forecast guidance, too. The plumes can sometimes be helpful to give us an idea of heavy rain potential, heavy QPF. And on the top, well, actually, the plumes are for the Hyannis area in Barnstable County, right there in the Cape Cod, where I'm showing the cursor. So these are 4 SREF runs with from, let's see, 9Z on July 6th through 3Z July 7th. And the SREF guidance was actually not very consistent, but at least as we headed closer to the flood event, to the 3Z guidance, it was showing the maximum QPF, but still the mean was only around 0.6 inches. And looking at the plume showing all the members of the 3Z July 7th SREF run, which is, like I said, is closest to when the flooding occurred, the mean was, again, around 0.6 inches, but even the maximum member, the wettest member, was only about 1.3 inches, which, as you'll see as we head further and further into the presentation, that was still greatly underestimated. So the highly variable guidance that was shown in the models, again, showed the need for monitoring near-term conditions using GOES 16 satellite imagery and other data sets, which will be shown.
And then this is the upper air sounding from OKX, the New York City office on Long Island, taken 12Z in the morning of July 7th. The sounding does show a very moist atmosphere in place. We see skinny cape in conjunction with very weak shear. That's a classic sign for a heavy rain event. Other thing I'd like to point out is the precipitable water value is 2.23 inches. Wow, that's a lot, especially considering, yes, this is the Northeast, yes, it's July, we do get humid up here, but that is very, very moist. The K-index is 37, another indicator that we have a very moist atmosphere in place. So this sounding is just screaming heavy rain is possible. We have a very moist atmosphere in place. And then go to the next slide.
Yes, so the Chatham sounding did have a little bit of a dry layer at low levels. However, the precipitable water was over 1 2/3 inches. Looking at the wind flow pattern, though, with the low-level winds from the south and then at the boundary layer from the southwest, it could be implied that some of the conditions that we saw at the Upton sounding were going to advect into the Cape Cod Chatham area later on in the day.
So just to hit the point home as to how moist this atmosphere was, this is the climatology for the precipitable water values for OKX, and just showing in July the precipitable water values do tend to range between 1.5 and 2 inches, but in terms of the overall extremes that OKX has ever measured for precipitable water values in July, the reading taken on July 7th is challenging some of those records. It ranks among some of the highest ever recorded on this day climatologically. So that just exemplifies how moist and that atmosphere was on Long Island.
So we have some Storm Prediction Center mesoscale analyses, which are very helpful, monitoring near-time conditions. And this loop is from 12Z to 18Z on July 7th. And it can be seen that the high precipitable water values were, in fact, advecting east and north into the Cape Cod area, just as what the sounding sort of implied, the 12Z sounding. So the mesoscale analyses were verifying that the deepest moisture was advecting through southern New England and toward Cape Cod.
And then here are the 3 water vapor channels from GOES 16, the morning of July 7th. Both or all 3 of these channels really nicely exemplify the 3 main features that help forecasters pinpoint which areas in question would see the heaviest rain. First feature I'd like to point out is the primary upper level impulse located over the Great Lakes, Ohio Valley region that is progressing eastward. Then downstream, we see the classic baroclinic leaf developing over the lower Hudson Valley, just north of New York City, into western New England. That feature really is more commonly seen in wintertime situations, more so than summertime. So seeing a baroclinic leaf in early July is pretty anomalous, and that is just showing how much upper level lift there was thanks to that shortwave advancing in from the Great Lakes. Another feature, you can see some very cold cloud tops off the Long Island and Nantucket shores. You can see the greens and the blues is indicating how deep that convection was. There is a warm front oriented along the southern New England coastline, so we'll eventually see how all of those parameters kind of came together. Another thing is there is a very strong tropical connection from the Gulf of Mexico. You can see nicely streaming moisture from the Gulf of Mexico towards the northeast United States, so a lot of moisture is getting pumped up from the Gulf, providing extra moisture for our eventual heavy rain event.
Okay, so we also monitored the visible imagery, which showed it revealed a surface low south of Long Island very clearly, much clearer than some of the old legacy GOES satellite imagery. We also had the baroclinic leaf that Christina was describing moving east. We also we're monitoring the convection along the warm front that was headed toward Cape Cod. And looking at all three of these features, they're actually trending toward merging with each other, showing that the threat for heavy rain was definitely headed for parts of eastern Rhode Island and into Cape Cod. So again, monitoring these three features in the satellite imagery along with other data sets showing the merger that was about to occur over Cape Cod really alerted us to the possibility. It alerted the Upton office and the Taunton office of potential flooding.
And then just showing another piece of guidance that helps forecasters on this day. I'm looking at the SPC mesoscale analysis, 850 Frontogenesis. We can see a nice concentration of Frontogenesis that was indicated over Cape Cod and southern New England and eventually expanded into the New York City area. The ASD from Upton that morning nicely indicated that they did notice and did acknowledge that Frontogenesis developing, so everyone was just looking at that feature as well as aiding the heavy rain event.
We also had strong surface convergence, with the highlights in red showing where the strongest surface convergence was. It almost lined up perfectly where the 850 millibar Frontogenesis was. So basically the screaming signal here was that we had strong low-level convergence, a lot of deep moisture. We had those features in the satellite imagery showing the convection and the merger of those features. So, you know, the threat for heavy rain was definitely increasing, and weather officers in the Northeast were definitely identifying these features and getting ready for a potential flood event.
Here's just showing snippets of the morning area forecast discussion issued from the various offices, Taunton, New York City, and Albany. All three indicated the prominent thermodynamic features and satellite near-term guidance. Especially Taunton, they actually explicitly acknowledged GOES 16 data and how they used it for their forecasting in nowcasting. So just want to point out that it was used, GOES 16 was used during the event, and Taunton does explicitly state that.
Yes, and they also, put a headline in their area forecast discussion before the flooding occurred that they were monitoring for the flash flood risk. So here are some of the products that the National Weather Service in Upton issued for the flooding associated with the baroclinic leaf, which you can see on the radar here. They actually issued a flood warning for an urban and small stream flood warning for parts of southern New York. And eventually there was enough rain where they had river flooding. So this definitely was a fairly widespread heavy rain that even actually affected some of the rivers in their area. So, and that was associated with the baroclinic leaf, not even associated with the convection that was headed toward Cape Cod.
Just to point out how heavy this rainfall was, this is a METAR from JFK, and we can see between 15 and 16 Z, over an inch and a quarter of rain fell. That is a very, we all know JFK is a very popular airport, highly congested, highly populated area. So for the rain to fall during the morning rush hours, that is just showing how impactful this rain event was. And both LaGuardia and JFK, or Kennedy Airport, both of them set daily rainfall records for the day. JFK and LaGuardia, both of those rainfall amounts, actually, most of them were measured during the morning hours within just an hour or two. So about 1.5 inches to almost 2 inches of rain took place in a very highly populated area.
So moving on to moving east to where the convection actually developed south of Cape Cod and eventually crossed Cape Cod, the Weather Service in Taunton did actually get some lead time with some flood products. So they initially issued a flood advisory for the heavy rain that was approaching the Cape, and eventually upgraded to flood warnings before the flooding actually occurred. And that's a typical stepwise increase in the products that is typical in the Northeast because we have to monitor these near-term trends. So with the uncertainty that existed, we did have to do, or they had to do the stepwise upgrade from flood advisories to flood warnings. But again, they got lead time, thankfully, before the flooding occurred in Cape Cod.
This is just a stage 4 precipitation analysis showing how much rain ended up falling. We can see two areas that really had the highest amounts. First, over northern New Jersey, lower Hudson Valley, New York City, they had pretty much widespread 1.5 to 2.5 inches of rain. And then further downstream on Cape Cod by the canal and Hyannis that we looked at earlier, there was a bullseye of 3 to almost 4 inches of rain. Again, Cape Cod on a Friday during the summertime, that would be probably full of people heading to the Cape for the summer weekend. So this heavy rain event did impact an area with probably a lot of people heading that way.
So we just wanted to show some of the flood warning polygons from the Upton office and some of the flood reports. So there were some very, very highly trafficked roads that were closed in the suburbs of New York City. You can see that even the Bronx River Parkway. There are definitely some urban areas, but still, with closed roads and with a high impact on the traffic in the area, this definitely was at least a high-impact event. And again, Upton had anticipated the flooding and issued their flood product with some lead time.
Taunton did the same thing. They had numerous polygons issued due to the heavy rain over Cape Cod. There were closed roads, flooding in basements, flooding in some restaurants actually, and we see one of them actually has 12 inches of standing water on a street. So there was a significant amount of flooding in some areas. And then we do on the left-hand side, we have some pictures thanks to some of the spotters in the Taunton CWA. We can see a lot of flooding in those pictures as well.
So some of the takeaways, let's see. So the model guidance and the Weather Prediction Center guidance highlighted the potential for heavy rain and flooding 2 days in advance. The GO-16 experimental satellite imagery made identifying and tracking synoptic and mesoscale features contributing to heavy rain and flooding easier than the legacy low-resolution satellite data. And the combination of data sets, the GO-16 data, radar, SPC mesoscale analyses were critical for situational awareness that led to flood warnings prior to the observed flooding. And again, in the lower part, you can see some other additional pictures of the flooding that occurred on Cape Cod. So with that, we'd like to acknowledge Dan Bykos. Thank you for all his help in getting this presentation together. And Brian Mata also, who gave us a lot of help putting the presentation together. And the Storm Prediction, Weather Prediction Centers with all the data they provided. And the staff of our office in Taunton and Upton for all their assistance in with all the products and all the guidance they gave us for analyzing this event. And also the Scientific Service Division at Eastern Region Headquarters for their review of this presentation also. So with that, we open it up to some questions. And thank you very much for your time.
Any questions or comments for Neil or Christina?
I guess I'll ask one. This is Scott at Sims. So the GO-16 has better spatial and temporal resolution, and I'm guessing, you can tell me if I'm wrong, that the increased temporal resolution for this, for such a I mean, for a flooding event, isn't going to be quite as useful as the spatial. Is that? Do you think for this case that's a correct statement? And if it's not, why not? How's that?
That's a fair question. I would say yes. The higher temporal resolution is definitely an improvement over the legacy imagery. We can monitor not only the higher resolution spatial data, of course, helps us to identify certain features, but of course, being able to track the features minute by minute probably is a little more useful than the spatial resolution, although both are so good. I mean, honestly, every day I look at it, and I enjoy both, and both are very useful, but seeing the cooling cloud tops minute by minute is very helpful also, because in the lower temporal resolution satellite data, you can sometimes miss those really short-term changes in cloud top temperatures and other features. So honestly, getting the 1 minute and 2 minute data is very, very helpful. But I don't know, I'd almost say the balance between the spatial and temporal improvement is almost equal, because it's just such good data.
I feel like I just asked you to decide which of your children you love better.
Yeah, I know. And, with my two sons at home, I always make sure that, I have a good balance for them.
And now you don't have the data for 2 weeks, but it'll come back.
But that's okay, because the data is coming back right when the real heart of nor'easter season starts. So we look forward to seeing that.
Yeah. Thank you.
Okay, any other questions for Christina or Neil? Well, hearing none, we want to thank Christina and Neil for leading today's presentation, and if you're interested in leading one in the future, just let us know. Our next webinar will be 1 week from today, next Thursday at 19Z, and the Monterey, California WFO will look at the historic wildfires they had back in October. Thanks, everybody, and have a great day.